All right, welcome back. Mr. Martin here. We are on 9.2, factoring quadratics. We're going to start off with monic trinomials, and we're going to use what we call the factor by grouping method. And we're also going to identify some special case quadratics. This is a concept that is going to be thoroughly used throughout your math career. If you take a look, we got a ton of standards down here that we're going to meet, so you really want to make sure you master these next coming sections. All right, first of all, our things to know. Remember, a quadratic trinomial, this is a polynomial with a degree of 2, meaning the variable term with the largest exponent is a 2, and it does consist of 3 terms. Standard form is hugely important to us, and it looks like this. So remember, at any point, if I'm going too fast, please pause the video, make sure you get this stuff written down. I got a lot to cover, so I'm going to try and go pretty quick and not make this a long video. But this is our standard form here. The a and the b, these are our coefficients for our x squared term, our x term, and then we have the c term, which is our constant, meaning it is just our number term. There is no variable there. That is our non-variable term. And the a is our leading coefficient when we are in standard form. We've done this before in the polynomial unit, so if you need to, please go back and check that one out. Okay, and a monic trinomial means that a value, the leading coefficient, has a value of 1. Alright, some skills that we need for this section. We need to know our factors, what factors are, how to do sums and differences, perfect squares, adding and subtracting polynomials. Okay, these are all previous units, so please refer back to the older videos if you need assistance with any of those. Alright, jumping straight in. The first thing we want to know is how to actually factor a trinomial, and this is our factor by grouping method. I have 9 steps here. I know they're lengthy and maybe a little wordy, but as you go through them, you'll find out they are not that difficult. Okay, keep this little list handy with you as you go through these problems, and the more you do, the less you will need to look at this list. So I'm going to start here with this box on the left. I want to recall, what is this following expression comprised of? We got n plus 6 times n plus 7. Well, if we look, we have 2 terms and 2 terms, and we have exponents of 1 on both of these. So what we have here are 2 linear binomials. Okay, these are 2 linear binomials, and we want to actually evaluate this. So we're going to multiply these out, and we are going to get n times n, which is n squared. N times 7 is going to be positive 7n. 6 times n is 6n. And then 6 times 7 for 42. Remember, we always combine like terms. These are the 2 in the middle. So we now have n squared plus 13n plus 42. This is fully evaluated out. And if you look down below, it is asking what type of polynomial is the result. And you might have said it in your head already. Boom, it is a quadratic trinomial. We have a quadratic because we got that exponent of 2, and then we have 1, 2, 3 terms. Alright, so I got this, our quadratic trinomial here. We want to go the opposite direction. We want to get this down to 2 binomials. So the first thing I like to do is find my a, b, and c values. Okay, I already got that down right here. I am looking at the coefficients. So this is my a, 1, 15 is my b, and then my c is 56. Alright, so that is step 1. Step 2, it says to find your a times c value. So I did that here. If I did a times c, I'm going to get 56. So step 2 is complete. Okay, and then step 3, it wants me to make a t-chart of all my factors of 56. So I'm going to do that right here. And I found all of my factors of 56, 1, 56, 2 and 28, 4 and 14, 7 and 8. Okay, step 3 complete. Now it wants to find 2 factors that add up to the middle term. If we look here, 7 and 8 are going to add up to 15, so that is what I'm looking for. That is going to be my middle term. So step 4 complete. Now it wants us to rewrite the expression by dropping down your a term. Okay, so if we took our a term, that is b squared. So I'm going to drop that down. Then it wants to rewrite the middle term as a sum of terms. So I'm going to split up this 15b into 2 terms and make them the sum of terms. Well, what b plus what b would equal 15b? Well, that would be 7b plus 8b. Okay. Remember, 7b plus 8b is going to equal 15b. And then it says to drop down my C term. So that is going to be plus 56. Okay, step 5 complete. We are almost done. All right, step 6, group your first two terms and group your second two terms. So I'm going to group my first two. That's b squared plus 7b. And then I'm going to group my second two. Remember, always group including the sign because those signs are attached to those terms. All right, so that is complete. Then it wants us to factor out the GCF. This is a skill from 9.1. And we're going to do this for both groups. You might want to write that down here. Both groups. I forgot to put that in. So my GCF of b squared plus 7b, that is going to be just a b. And then I have b plus 7 remaining. And then 8b and 56. Looks like I can take out a positive 8. And then I am left with b plus 7. All right. Yay! Make sure the terms in the parentheses match. So this is step 8, and if we look, b plus 7 does match b plus 7, so we are good to go on step 8. That looks very good. Then it says to group the two GCFs. That is this b and this 8, so it wants me to group those. So I'm going to do b and positive 8. And then it wants me to place it next to the remaining binomial, which is our match of b plus 7. Okay, and now we are fully factored out. That is all of the steps. This is what we are looking for. We wanted to go from a quadratic trinomial to my two linear binomials. And if we were to evaluate this out, we would get b times b, which would be b squared. B times 7 would be 7b. 8 times b would be 8b. And 8 times 7 would be 56. And if we combine these like terms, we would get b squared plus 15b plus 56. So we are back where we started. Nothing has changed, but we have actually factored that into our two factors. So this is what we are trying to do in this unit. All right, or this section of this unit. All right, let's go to example number 1. It says factor the trinomial and then perform a check just like we did on the last one. So remember, the first thing I like to do is I like to find my a, b, and c, and then I found my factors for my a, c. So does 7 plus 1 give me 8? It sure does. We are in the right direction. So let's go ahead and drop down that a term. So we got a squared. We're going to rewrite this 8a as plus 1a. So we can just put plus a. And then we got plus 7a. And then we drop down the c term. All right, then it wants us to group and group. All right, then I want to factor out my GCF. A squared and a looks like I can take out an a, and I would be left with a plus 1. And then here it looks like I can take out a positive 7, and then I'm left with a plus 1. Do these two match? They sure do. We are in the right place to be. So we can go ahead and group these, a plus 7, and then we got a plus 1 right next to it. So that is my factored form. All right, let's do a check. I think I already have it down here. I sure do. I'm going to take that out. So if we were to multiply that out, a squared plus a plus 7a plus 7 gives me that a squared plus 8a plus 7. We are back where we started. All right, let's take a look at the second example. We got v squared minus 18v plus 80. Remember, we want to find our a, b, and c, and our ac, and then all of our factors. Okay, remember, if you need to pause the video and write these down, please pause and then come back for the explanation. Here, I'm trying to find two numbers that add up to negative 18. Well, all of these look positive. How do I get a negative number from here? Well, that's easy. I can go ahead and assign negative values to these, and the reason being because negative 8 plus negative 10 would give me negative 18. And what happens when we multiply negative 8 and negative 10? We get a positive 80. So this is my two middle terms that I'm going to rewrite. So let's drop down this v. We got v squared. We're going to rewrite this as minus 8v, and this is going to be minus 10v. Remember, we are splitting this guy up. Okay, and then we got plus 80. All right, so we want to go ahead and group and group. and group and group. All right, v squared minus 8v, we can take out a v and we are left with v minus 8. Okay, now here is something to remember. If your first term here is negative, we always want to factor out the negative. Always factor out the negative. So what can go into both of these terms? Well, if we take out a negative 10, okay, remember we are doing division. Negative 10v divided by negative 10, that's going to give me a positive v, which is what I want. 80 divided by negative 10 is going to give me a negative 8, also what I want. If we did not factor out the negative, you would have something wacky in here that does not look like here, and that would be no bueno. These need to match up. Alright, so let's go ahead and combine these. V minus 10, and then we also have v minus 8. So we are good to go. And let's go ahead and do the check. It's always good if you pause and try the check first. I'm just going to pop this bad boy out of here. Boom. Looks like we are good. Alright, and moving on to the final one. This one is a little bit different. So after I found my A, my B, and my C, it looks like I have a C value that is negative. Both of these were positive over here. Okay, so let's see how we're going to do this. Well, if I do any of these adding up, 32 and 1, 33, 18, 12, if I made these negative, negative, and negative, well, think about this. If we're multiplying two numbers and we need it to be a negative, that means one of them has to be a negative, right? Because a negative times a positive will always equal a negative. So we need one to be positive, we need one to be negative. Okay, and if I am looking for a positive 4, I need something minus something to equal 4. 32 minus 1, 16 minus 2, whoop. 8 minus 4 would give me a positive 4, so that means this needs to be negative, this needs to be positive. Alright, so let's go ahead and write this out. We got b squared. We're going to split this up. This will be negative 4b. This is going to be positive 8b, and then minus 32. We're going to go ahead and group these. Boom and boom. Alright, so I now have b minus 4. I'm going to take out an 8, and then I got b minus 4. Alright, so we got b plus 8 and b minus 4. We are good to go. Alright, so let me do my check. Boom, down here looks like we are good. I forgot my little green check mark. I'm going to slap that on right there. Alright. Find that pattern. Looking at the three different monic trinomials from example 1, write down a few things that you notice. Go ahead and pause the video here. Jot down your thoughts and then come on back and see what I got. Alright, pause it. Alright, welcome back. This is what I got right here. The signs on the B and C terms are different throughout the examples. Okay, and this is actually that you're going to see as you work through these. There are three different types that you're going to see, so I'm going to give them to you here. The first type, we have ax squared plus bx plus c. So this is what I like to call plus plus, where my b is positive and my c is positive. And what that means for me at the end, okay, after I am done doing all my work, that means I will have x plus and x plus. Okay, both of my binomials will have positive and positive. The second one, I got a negative b term, but again, my c is positive. Okay, so positive c and positive c. That means with a negative b, I am going to be minus minus. This is what my end result should look like. And remember, this is just some number here. So whatever numbers those are. And then the last one is where I have a negative c term. So whether my b term is positive or negative, if I have a negative c term, that means I will end up with opposite signs in my binomial. So it could be x plus times x minus, and it could go the other way too. Doesn't matter. You just know that you are going to have opposite signs. And I do got a little extra tip down here. When your c term is negative and you're finding your factors, the sign of your b term. So if this is positive, that means it'll be assigned to the larger factor. So just like here, in our previous example, Our b term was positive. That's why the positive went to the bigger factor. So that's just something to help speed you along the way. All right, let's go on to example number 2. This is just like example 1. It says factor the trinomial and perform a check. You are going to pause the video here. I got 3 examples. I've shown you what you need. Look for if it's going to be plus plus, minus minus, or plus minus. Try these out and then come on back. Alright, welcome back. I know some of you guys didn't pause the video and do them. For those of you that did, awesome. I know you did. Alright, so let's go ahead and go through these. Alright, so this first one, we have a negative c term, so that means I should end up with a plus minus, and I got v plus 7, v minus 3. Alright, and then the second one, positive and positive, that means I'm going to end up with a plus plus. That's like that first example. And we got b plus 10, b plus 5. And then last but not least, my c term is positive, but my b term is negative, so I'm going to end up with a minus minus. Alright, remember, all these do is just take some practice. You will get good at them, I guarantee it. Alright, moving on. Example number 3. This one says to factor the trinomial and solve. So we are doing a little bit of 9.1. Remember, in 9.1 we had the zero product rule. We are going to do the same thing, but first we are just going to factor, and then we are going to solve. So the first thing first, I need to find my AC. Okay, I think we're getting kind of comfortable identifying A, B, and C. So I just did the AC right here. We got negative 32. I need them to be 4. Remember, I said if it is a negative c term, the sign of my b term will go to my bigger factor. So that means I'm going to have a positive 8 and a negative 4. So we're going to do p squared minus 4p plus 8p minus 32. Alright, boom and boom. Let's go ahead and group these. And then we factor out that GCF. So I got p minus 4. And then I'm going to take out a positive 8. And I'm left with p minus 4. And remember, this is equal to 0. So now we got p plus 8 times p minus 4 equal to 0. So I got 2 factors equal to 0. I need to put the zero product rule and set each of these factors equal to 0 and solve. So p plus 8 equals 0. Well, if I subtract the 8 from both sides, I'm going to get p is equal to negative 8. So that is my first solution. And then we got p minus 4 is equal to 0. I'm going to add a 4 to both sides, and I'm going to get p is equal to 4. Okay, one thing you can know is when you're down at this part, remember, this 4 is really just the opposite of this negative 4. That is my solution right there. So I got these two. If you wanted to put them in set notation, you could do negative 8 comma 4. Alright, let's go ahead and pause the video here. I'm going to let you do this one on your own. Pause the video here and then come on back. Alright, welcome back. So I got 8 and 10. Those are my values to get my zeros. Alright, looking at the last one. What are my A and C values? Am I in standard form? That is the big question to ask. I am not. So this is what I need to make sure I do first. Okay, remember, we can't find that A, B, and C until we are in standard form. So I needed to move this negative 36 all the way to the left. That way I can set this equal to 0. Remember, that was also one of my tips from the last section, was always have everything to one side and then set it equal to 0. So I got a negative b term and a positive c term. That means I'm looking for 2 negatives, so that's going to be negative 4 and negative 9. Let's go ahead and rewrite this. So n squared minus 4n minus 9n and plus 36. We want to group these and group these. So it looks like we take out an n. We got n minus 4. I'm going to take out a negative 9. I am left with n minus 4. Alright, so now we got n minus 9 and n minus 4 is equal to 0. And we can actually kind of already easily eyeball this. What minus 9 will give me 0? Well, that's going to be a positive 9. What minus 4 will give me 0? Well, that's going to be a positive 4. So these are my answers right there. All right, boom and boom. All right, last but not least, we have our special case trinomials. All right, so I want you to pause the video here, evaluate this one out, and show me what you get. All right, welcome back. So I evaluated this out. If we combine these like terms, 3x minus 3x, that's going to give me a 0. So my b term is now 0. So I'm left with x squared minus 9. Now, if you remember, I said some of the things that we need to know in this section are our perfect squares. So what is the coefficient of this x? It is a 1. Is 1 a perfect square? It sure is, because 1 times 1 equals 1. Is x squared a perfect squared? Well, what's x times x? Itself times itself. That is x squared. So that is a perfect squared. What about this 9? Is 9 a perfect squared? 3 times 3. Yes, that is a perfect square. Okay, so if we look at these two binomials, can we draw a connection to this x squared minus 25? I want you to pause the video here again. See if you can get to your factored form without doing the AC method. I'm going to talk about it after you come back. All right, pause the video. All right, welcome back. So I'm glad you thought about it. And if we take a look, the thing about difference of squares is we want to ask ourselves, are two terms all perfect squares? So if we look at the coefficient of this one, do we have a 1? Yes. 1 is a perfect square. X squared, yes, that is a perfect square. Is 25 a perfect square? Yes. So the only thing that's different from here and here is this 25 was a 9. So how did we get from 9 to 3? Well, that is a square root. So what times what will equal 25? That is going to be 5. And then here are binomials. We had a plus and we had a minus. We're going to do the same thing here, plus and minus. Because what happens if we multiply this out? Our two middle terms are going to be minus 5x and plus 5x, and those are going to equal 0. So 5 times negative 5 is going to be minus 25. Now you could do the A, B, and C, and I'd like you to try that on your own, but at this point, what is your B value? That is going to be 0. So when you find your factors of 25, that is going to be 5 and 5. Which two will end up being 0? We have a negative C term, so that means we need one positive and one negative, which is what we have right here. So I want you to identify if any of these are perfect squares, and that means you want to look if this is a perfect square and if this is a perfect square. If it is, go ahead and factor it, pause the video, then come on back. Alright, welcome back. So this first one, x squared is perfect squared, 36 is a perfect squared. What is the square root of 36? That's 6 right there. So I got x plus 6, x minus 6. Easy, so simple. Difference of squares are really easy to do as long as you can identify them, and that means it is the square root of this term, and you just make sure one is positive, one is negative. So 34, not a perfect square, so this is not a difference of squares. 10x, not a difference of squares, because that x is not even a perfect square, nor is that 10. And then here we have x squared and 1. These are both perfect squares, so we got x plus 1 and x minus 1. That is our difference of squares. Very important to identify these. You're going to see them a lot in Algebra 2, so make sure this is one that you remember for the books. Alright, last but not least, I might have said that already, but this is our last example. We actually have what we call the sum of squares. And remember, this we have seen before. If it is something times itself, we actually can write it like this, and it looks like this. And when we distribute, okay, we end up getting x squared plus 7x plus 7x plus 49, and then we get x squared plus 14x plus 49. Okay, so I want you to take a look at this and see if there is any kind of pattern that you recognize, anything that is special, anything that is unique and interesting about it, and then we will talk about this one. Go ahead and pause the video and then come on back. Alright, welcome back. So I went ahead and did the AC of 4, and if I added 1 and 4, that would give me 5, so that's not my middle term. 2 and 2 would add up to 4, so that's what I'm looking for. So I rewrote 4x as 2x plus 2x. I did my GCF, blah, blah, blah. And then I ended up getting x plus 2 times x plus 2, which we could actually write as x plus 2 squared. But I wanted you guys to see if you can identify what is unique about these values. Okay? When you have a sum of squares, one thing you can look for, and you can ask yourself this, is the square root of my c term, well, what is the square root of my c term? That is 2. Then 2, right, times 2, if I multiply it by 2, does that equal my b term? And it does. So if you are looking at your quadratic trinomial and you say, hey, well, if I were to square root my c term and then multiply it by 2, does that equal my b term? And if it does, then you have a sum of squares. So let's try that right here. What is the square root of 25? That is going to equal 5. And then if I double that 5, does that equal my b term? Yes, it does. So then that means all I have is matching binomials of the square root of my c term. So this is going to be x plus 5 times x plus 5. And if you were to multiply it out, x squared plus 5x plus 5x, 5 times 5 is 25. These combine to 10x, and then x squared plus, and we are back where we started. So pause the video, check these other three, and see if these are sum of squares, and if they are, then go ahead and factor them out. All right, fantastic. You notice that all of them were sum of squares, right? Square root of 81 is 9. 9 times 2 is 18. Boom, we can write it down just like that. We don't need to follow all of these steps because we were able to identify a sum of squares. That's why it is important to remember all of these special cases and all of these rules that are introduced, because sometimes it will save you a ton of scratch work. So same thing here. Square root of 49 is 7. 7 times 2 is 14. Boom. Square root of 1 is 1. 1 times 2 is 2. Looks like it applies for all of these. All right, so last but not least, what do you notice about the qualities of difference of squares, and what do you notice about the qualities of sum of squares? And I just basically wrote down what I said in the last example. So if you want, write this down. That way you have it in your notes when you're taking a look at it. You can go over it. All right, so my apologies. I know this was a lengthy video. This is the forefront of learning how to factor, so it took me a little while because I really wanted to dive in and explain it, and hopefully you got enough from it. If you need to go back and revisit it, go back and revisit it. As always, it's been a pleasure. I'll catch you on the next one. Peace out.